Hey, this is Will, and in this lesson, we're going to be talking about the Kubernetes networking model. So, networking is one of those things that tends to trip people up when they're learning about Kubernetes. My theory on that is I think that's because most of the people that are interested in Kubernetes come from a system administration background or a DevOps background, and they may not always be familiar with all the details of networking because they don't come from a networking background. And I think that might be why networking tends to trip some people up. So in order to really understand what's going on and provide some background knowledge to help you as we're implementing Kubernetes networking in this section, I want to talk about the overall architecture of how Kubernetes does networking and what exactly is it that we're setting up when we set up our networking. I've got a link here to the official documentation. You can go there to learn more about Kubernetes cluster networking. This lesson is really kind of a summary of what is contained there in the official documentation. So you can find more detailed information there if you want to learn more. So I want to start off by talking about what problems does the Kubernetes networking model solve. I think by talking about these problems, we can kind of begin to understand what exactly the networking model is. The Kubernetes networking model is essentially an architecture that provides solutions to the problems that I have listed here. So how are containers going to communicate with each other? If I've got one container and I need to communicate with another container over the network, how are we going to handle that? What if those containers are on different hosts? In Kubernetes, we have a distributed system. We have the ability to have multiple worker nodes. What if one of my containers is on one worker node and the other container is on another worker node? How are those two going to communicate with each other? What about services? Kubernetes has the ability to implement services. What if one of my containers needs to communicate with a service? How do I handle that communication? And of course, how can we make sure that containers are assigned unique IP addresses and what ports are going to be used? These are the kinds of questions that the Kubernetes networking model intends to provide an answer to. In order to really understand the Kubernetes networking model, though, we need to understand the Docker model. And the reason for that is that the Kubernetes networking model is a response to the Docker model. It's an attempt to overcome some of the limitations of the Docker model. So here is how Docker implemented the ability for containers to communicate with each other. It allows containers to communicate with one another using a virtual network bridge configured on the host. So if I have multiple containers and they're all running on the same host, they have a virtual network bridge that they can use to communicate with each other. Each host has its own virtual network that's created using that virtual bridge, which serves all the containers on the host. So you can think of each host as being its own sort of self-contained virtual network. But the problem is, what about containers on different hosts? Well, we have to proxy traffic from the host to the container. So if I want to access a container from outside, or I want to access a container from another container that's running on a different host, what I have to do is I have to set up a proxy on the host that listens on a particular port, and any traffic coming into that port on the host will be rerouted to that particular container. As you can imagine, that can become kind of complicated because if I have multiple containers on the same host, I have to make sure that they all have a unique port because none of them can use the same port, and I have to handle all that coordination in order to proxy that traffic. And the more containers I spin up and the more complex my infrastructure gets, the more difficult that can become to manage. So the Kubernetes networking model was created to overcome some of those limitations. So here I have a diagram of the Docker networking model. I just wanted to show you kind of a visual representation of it so that you could have a little bit better of an idea of what I'm talking about. As you can see, I have two Docker hosts, and each one is its own completely separate virtual network. So by default, this container over here on the right can't talk to any of these containers. So what we do is we set up a proxy that is able to listen for traffic on a particular port and proxy that traffic to one of the containers. So if this container over here wants to communicate with this container here, it has to go through this proxy. And if we have 3 containers over here, we actually have to set up 3 different proxies on their own unique ports. And again, with a large complex infrastructure, that can become very difficult to manage. So now let's talk about the Kubernetes networking model. The Kubernetes networking model creates one virtual network for the whole cluster. So while Docker has a virtual network for each host, Kubernetes has a virtual network that spans across all the hosts. So within that virtual network, each pod has its own unique IP address within the cluster, as well as each service. So services also have unique IP addresses, and those IP addresses are in a different range than pod IP addresses. So we have a range of IPs that can be assigned to pods, and we have a range of IPs that can be assigned to services. And each one of those has its own unique IP address. So if I'm a pod in the cluster, I can communicate with any other pod in the cluster, no matter which host it's on. And I can also communicate with services. All I need to know is the IP address of that pod or that service. So let's look at that in diagram form. And as you can see here, whereas Docker had a separate virtual network for each host, there's one single virtual network that encompasses both of my Kubernetes nodes. So I've got some pods over here on the left, and I've got a pod over here on the right. And if one pod wants to talk to another pod, all it needs to do is contact that pod via its IP address. And it doesn't matter whether the pod is on the same host or whether it's on a different host. My pod should be able to communicate with it no matter what using that virtual network. So that's how the Kubernetes networking model works. In the next lesson, we'll talk in a little bit more detail. What exactly does that mean for us? How do we go about implementing that within this cluster that we're trying to build? But before we could get to that point, I wanted to make sure that you had some idea of the basic architecture of Kubernetes networking so that you would have a foundation to help you understand what exactly we're trying to implement.